Welcome to Gurukulplex's presentation on mastering calculus. Gurukulplex is an online education platform from kindergarten to class 12. Today we will learn about calculus and its uses. So, let's get started. Calculus has been a fundamental part of mathematics for many years. It has been deployed to create and resolve intricate real-world predicaments in engineering, physics and economics. This presentation will look into the fundamentals of calculus, such as limits, derivatives, integrals, differential equations and series. Also, we will investigate how calculus can be applied in numerous areas to obtain a more profound understanding of the environment surrounding us. So, let us commence. Calculus is a branch of mathematics that focuses on the concept of infinity. It studies rates of change and how things change over time, divided into two main branches: differential calculus and integral calculus. Differential calculus is used to analyze slopes of curves and rates of change, while integral calculus is employed to determine areas under curves and volumes of three-dimensional objects. This tool is widely used in physics, engineering, and economics. Calculus is a powerful tool with a variety of applications in different domains. Engineers apply it to design bridges that can bear the heaviest load without destruction, whereas in physics, it is used for estimating the path of a projectile, as well as its speed and movement. Economics leans on calculus to determine production and consumption options that optimize performance. Moreover, calculus is employed to simulate the spread of illnesses, population growth, and the performance of financial markets. Therefore, calculus enables scientists and engineers to make accurate predictions of how these systems will act when faced with various circumstances. Limits are a crucial element of calculus and are a must for understanding multiple functions. The example of f(x) equals x caret 2 to 1, x1, demonstrates how limits are employed to discover the value a function tends towards as its input approaches a given value. Limits also offer us a way to analyze other math functions, giving us a better insight of how these functions behave. Derivatives are a powerful tool to both comprehend our world and make improvements to it. As with any other tool, it must be utilized intelligently and cautiously. When appropriately employed, derivatives can give companies, governments, and people the insights and facts they need to make informed choices that will encourage sustainable increase and advantage society in the long run. To calculate derivatives and simplify calculations, several rules of differentiation can be applied. The power rule, product rule, and chain rule all provide ways to accurately and quickly calculate derivatives. The power rule states that if a function is raised to a power, its derivative can be found by multiplying the exponent by the coefficient and subtracting 1 from the exponent. The product rule is used when two functions are multiplied together, where the derivative is equal to the first function times the derivative of the second function, plus the second function times the derivative of the first function. Finally, the chain rule is used when a function is composed of several functions. The derivative of a composite function is equal to the derivative of the outer function evaluated at the inner function, times the derivative of the inner function. Derivatives are a vital element in numerous areas. They are employed to discover the most advantageous answer to a problem or to figure out the rate of change of physical proportions. In economics, derivatives are utilized to find out the utmost gain or minimal cost of a given situation. In engineering, derivatives are beneficial with regards to optimizing designs and increasing productivity. In physics, derivatives are utilized to calculate rates of change of physical proportions such as velocity and acceleration. This makes them essential in the contemporary world, with their utilization serving to form the future. Integrals are an essential concept in calculus which enables the calculation of the area under a curve. It has many practical usages, from finding the volume of a container to evaluating the distance traveled by an object in a given period of time. Integration is done by separating the area beneath the curve into smaller rectangles and totaling the area of each. As the rectangles get smaller, the sum of the area approaches the true area of the curve. This is the fundamental idea of integrals in mathematics. Integration rules are essential to simplify calculations when dealing with integrals. There are various integration rules to gain knowledge about when tackling integrals. The power rule is one of the standard rules and implies that if the integral of a function is raised to a power, then one can add 1 to the exponent and divide by the new exponent. Thus, the integral of x squared would be x cubed, 3. The substitution rule is another fundamental integration rule which permits to substitute a complex expression with a simpler one. This comes in handy when handling long and complex integrals. Integrals are intriguing mathematical instruments that permit us to figure out the territory under a bend. This misleadingly basic idea has ramifications that arrive at over material science, financial aspects, and designing. In material science, integrals can be utilized to ascertain the work done by a power, which administers movement and vitality. In financial matters, integrals permit us to compute optional income and cost, which are key in deciding the best creation levels. Integrals can likewise be utilized in designing to decide the volume of materials needed in building. With this, comprehension integrals and their applications can give gigantic knowledge into some unfathomably differing territories. Differential equations are a powerful tool in analyzing and predicting the behavior of physical and biological systems over time. These equations are widely applicable, used in engineering, physics, and biology to model the movement of objects under forces, the flow of fluids, or the transmission of diseases. Through studying these equations, accurate predictions can be made about the future state of a system. Partial derivatives are a powerful mathematical tool for analyzing functions of multiple variables. They enable us to measure how a function changes when only one variable is altered while other variables are kept constant. For example, in physics, partial derivatives are used to calculate the rate of change of energy when it relates to a single variable like temperature or pressure. In engineering, partial derivatives are utilized to optimize designs by determining how a change in one variable affects the overall performance of a system. Multiple integrals extend the concept of single integrals, enabling the computation of the volume and area of a function with multiple variables. To comprehend this concept, consider the notion of stacked rectangles, where the height corresponds to the value of the function at that point, and the width and length correspond to the size of the region. By adding up the contributions from each piece, we can calculate the area of the function. Series are a tool commonly used in calculus to represent functions as an infinite sum. Arithmetic series are created by adding a constant value to each term, geometric series are created by multiplying a constant value to each term, and power series are a polynomial function of x raised to a power. Series are also used to approximate functions, evaluate integrals, and also solve differential equations. The Taylor series is a powerful tool that is used to approximate any smooth function with a polynomial function. Power series are mathematical tools employed in multiple disciplines. It is an infinite sum of terms which is composed of a polynomial multiplied by a constant coefficient. Examples of power series are the Taylor and Maclaurin series, which are used to estimate the values of sine and exponential functions, respectively. These approximations are beneficial in signal processing, control systems, and other applications from the real world. Power series offer an efficient way to make precise presumptions and create comprehensive models of physical and technical systems. Calculus is essential to comprehend the intricacies of distinct areas. It aids us in pinpointing the rate of alteration in a certain situation, calculating areas underneath curves and analyzing functions. We have learned that getting acquainted with the basics of calculus such as limits, derivatives, integrals, differential equations, partial derivatives, multiple integrals, series and power series, allows us to come up with knowledgeable decisions when putting calculus to actual life circumstances. Thank you for your time and focus.